Hello students, in this video I will go through exercise U4A02A where we will be applying properties of sides, angles, and diagonals to identify a parallelogram. Okay, so for the first question here, question number 2, or actually let's read the instructions. So for 2 to 5, the quadrilaterals are parallelograms, so they're telling you that these are parallelograms. Find the values of each variable. So according to the properties of parallelograms, we understand that opposite angles are congruent. So therefore we can say that 75 is equal to 2x minus 1. Solving for x, we can then say that 76 is equal to 2x divided by 2. X will equal to 38. You could have also said that consecutive angles are supplementary. Either way, it's the same thing. All right. We understand that opposite sides are congruent, so therefore we say that 11 is equal to y minus 4. Add 4 to both sides, y will equal to 15. In a parallelogram, the diagonals bisect one another. So because of this, we can say that 2 will equal to a minus 7. Therefore, a will equal to 9. And we can say that 2b minus 6 is equal to 10. Add 6 to both sides, we get 2b is equal to 16. Divide by 2, b is equal to 8. Again, the same exact property. The diagonals bisect one another, so we can say that 4w minus 7 is equal to 2w plus 3. Subtract 2w from both sides, add 7 to both sides, divide by 2, we get w is equal to 5. Again, 2b plus 5 is equal to 3b plus 1. Subtract 3b from both sides, we get negative b. Subtract 5 from both sides, we get negative 4. So therefore, b is equal to positive 4. Okay. Use parallelogram Pqrs to find each measure. So Pqrs, we're told that angle Q is 128 degrees. So therefore, angle R will be supplementary to 128, which gives us 52. QP will be opposite. QP is opposite of RS, so therefore QP must equal to 5. QR is opposite of SP, so therefore QR is equal to 3. Angle S is opposite of angle Q, so therefore this is equal to 128. For questions 15 to 20, the quadrilaterals are parallelograms. Find the values of each variable. So it's very, very similar to the first 4 that we did. So let's take a look. So here you're asked to apply the property that opposite sides are congruent. So therefore we say 3a plus 7 is equal to 4a. And I apologize for the blurry text there. I got this off of an image. At the time when I made this, the camera I was using was not that great. This is b plus 11 is equal to 2b. Again, we solve for a and we solve for b. So we subtract 3a from both sides. We end up with a is equal to 7. We subtract b from both sides. We end up with b is equal to 11. Question number 14. Angle y will equal to 101 because angle S is opposite of angle Q, and they are going to be congruent. Opposite angles are congruent. And consecutive angles are going to be supplementary. So x plus y, or x plus 101, is equal to 180. Subtract both sides by 180, we get x is equal to 79. All right, question 17. So the diagonals bisect one another, so therefore we can say that y minus 7 is equal to 10. Add 7 to both sides, y is equal to 17. x plus 6 will equal to 11, again, because of diagonals bisecting one another. Subtract 6 from both sides, we end up with x is equal to 5. Question 18. 3b minus 7, 3b minus 17 rather, opposite sides are congruent, so 3b minus 17 will equal to b minus 11. Solve for b, so subtract b from both sides, we end up with 2b equal to, add 17 to both sides, 2b will equal to 6, divide by 2, b is equal to 3. Again, a plus 15 is equal to 3a plus 11. Subtract a, subtract 11, divide by 2, a is equal to 2. Opposite angles are congruent, so therefore we can say that 2y is equal to 2x plus 11. However, because this equation has two unknowns, we can't really solve this. However, they did give us another piece of information, which is these consecutive angles. So we know that x minus 5 plus 2x plus 11 should equal to 180. Combine like terms, we get 3x plus 6 is equal to 180. Subtract 6 from both sides, we get 3x is equal to 174. Divide by 3, we end up with 50, what is this? 58. And since x is equal to 58, 2y is equal to 2 times 58 plus 11. So that would be 116 plus 11, so that's 127 is equal to 2y. Y, therefore, is equal to 127 over 2. Okay. Moving on, question number 20. The diagonals in a parallelogram bisect one another, so therefore 3y minus 5 will equal to y plus 5. Subtract y from both sides, we end up with 2y is equal to, add 5 to both sides is equal to 10. Divide by 2, we end up with y is equal to 5. Z plus 9 is equal to 2z plus 7. Subtract z from both sides, we end up with z is equal to, subtract 7 from both sides, z is equal to 2. Use parallelogram ABCD to find each measure or value. So let's try question number 31, which is to solve for x. So looking at which piece of information involves x, I notice that BC is 2x plus 7. BC is opposite of AD and they're congruent. So therefore we can say that 2x plus 7 is equal to 13. Subtract 7 from both sides, we end up with 2x is equal to 6. Divide by 2, x is equal to 3. Let's take number 32. And AB involves variable y, so we say 3y minus 8 is equal to, AB is opposite of DC, so is equal to 10. Add 8 to both sides, we end up with 3y is equal to 18. Divide by 3, y is equal to 6. We're solving angle AFB. So AFB will be supplementary to angle BFC because they're a linear pair. So AFB plus 49 is equal to 180. So therefore AFB will equal to 131. Next, we're solving for angle DAC. Angle DAC, well, since we know angle AFB is, since we know angle CFB is 49, then we know that this angle over here must also be 49. So, and DAC plus 49 plus 59 should equal to 180 because I have a small triangle. There are actually 4 triangles inside of a parallelogram, but each one of them, the interior angle should add up to 180. So I know that angle DAC plus, combining like terms here, 49 and 59 gives me 108. Subtract 108 is equal to 72. All right, we're looking for ACD. ACD. So since we know angle AFB to be 131, and we know that ABF is 20 degrees, therefore BDC should also be 20 degrees because alternate interior angles. So therefore, angle ACD should be supplementary to 20 and 131. So plus 20 plus 131 should equal to 180. Angle ACD plus 151 is equal to 180. Subtract 151 from both sides. Angle ACD will equal to 29. And then lastly, we're looking for angle DAB. So DAB is going to be the sum of angle DAC plus angle ACB or BAC. So since we know DAC, right, DAC is equal to 72 because we just solved it in question 34, and BAC is going to be equivalent to ACD, which we had found in question 35. And why is that? Well, that's because of alternate interior angles. So if this guy over here is 29, then this guy must be 29. That's because of alternate interior angles. So if we add them together, we end up with 90... No, I'm sorry, we end up with 101. Okay. All right. Challenge. Okay, ABCD is a parallelogram with side lengths as indicated in the figure on the right. The perimeter of ABCD is 22. Find AB. So, don't be intimidated by the word challenge, just because it's all applying very, very similar concepts. Probably the only thing challenging is you're going to have to apply more algebraic know-how in solving these things. So it turns into less of a geometry problem and more of an algebra problem. So I know that 3 minus 4w is equal to 2y plus 1. And I also know that 3x minus 2 is equal to x minus w plus 1. So looking at this, I have 3 unknowns. So if I were to bring everything over to one side, like all the variables over to one side, that is, I'll end up with this guy here being 2x plus w is equal to 3. And then the one above, I'll end up with, let's see here, 2y plus 4w is equal to 2. And it says here the perimeter is equal to 22, right? So what does that mean? Well, that's how we're going to get our third equation, because right now we have 2 equations. However, we have 3 unknowns. So 22, what we're going to do is we're going to add everything together. Okay, so if we add 3 minus 4w with 2y plus 1 with, actually I'm going to write this out. So I have x minus, I want to leave a little space, actually, x minus w plus 1, 3x minus 2, 3 minus 4w, I'll write it like this, and 2y plus 1. If I add them all up, I'll end up with 4x plus 2y minus 5w, and I add all this stuff up, so 1, 4, 5, 5 minus 2 is 3, so it's plus 3. All of this should equal to 22. So this is my third equation here. So what I'm going to do, since I have these equations, this is my third equation, this is my first, and this is my third. What I'm going to do is I'm going to create a systems of equation and solve for x, y, and w. Okay, so since I have w is equal to 2x plus w is equal to 3, I can then solve for w here. W is equal to 3 minus 2x. Okay? And if I do that, if I take this and I substitute it into this equation here, I'll end up with an equation involving, let me see here. I'm sorry. I take that back. So w is equal to 3 minus 2x. And since w is equal to 3 minus 2x, I can also take this and substitute this inside of this guy here. Right? And that's what I'm going to do. So I end up with 2y plus 4 times 3 minus 2x is equal to 2. And what happens then is I'll end up with y in terms of x, right? So I end up with 2y plus 12 minus 8x is equal to 2. I want to solve for y in terms of x, so I end up with w in terms of x and y in terms of x, okay? So subtract 12, I end up with 2y minus 8x is equal to negative 10. Add 8x to both sides, I end up with 2y is equal to negative 10 plus 8x. Divide by 2, I end up with y is equal to negative 5 plus 4x. So now what I'm going to do is I'm going to take these, the one I'm starring here, these two things, and I want to substitute it directly into this guy, so that I'll have one equation with one unknown. So 3 minus 2x is w, right? So I have 4x plus 2 times, what was y again? Y is negative 5 plus 4x. And w was 3 minus 2x is equal to 22. Distribute the 2, I end up with negative 10 plus 8x minus 15 plus 10x plus 3 is equal to 22. Combine like terms. 4, 8, and 10 gets me 22x. Negative 10, negative 15 makes negative 25. Negative 25 plus 3 is negative 23. Add 23 to both sides, I end up with 22x is equal to 45. Right. and divide by 2, I end up with x is equal to 45 over 22. I just want to make sure that I actually did all of this correctly here. Let me see here. 3 minus 4w is equal to 2y plus 1. 2y plus 4w is equal to 2. Yes. 2y. So therefore, 2y so therefore 3 minus 2x, 12 minus 8x, 12 minus 8x is equal to 2. Subtract 10, subtract 12, I get negative 10. Add 8x, I get, yeah, I did do it correctly. Funny how the x-coordinate turns out to be something very, very ugly looking. I'll show you in a moment how we can do this on a calculator too, if ever something like this presents itself. W, what will W turn into? W turn into 3 minus 2x, right? So it's 3 minus 2 times 45 over 2 times 45 over 22, which is 3 minus 45 over 11, which turns out to be 33 minus 45, which is negative 12 over 11. So that's W. I should have given myself a little more room when I put this together. And the last one is to find out what y is. Since I know what y is equal to here, y is equal to negative 5 plus 4x, it's negative 5 plus 4 times 45 over 11. So that's negative 5 plus 180 over 11, or 180 minus 55 is 125 over 11. All right, so I want to show you how to actually do this on a calculator. If ever something like this presents itself. So what I will do is I want to take this, take the equations that I have, okay? So this equation, 4x plus 2y minus 5w is equal to, I want to subtract 3 from both sides, I get 19. Right? So this is the first equation. The second equation I have is 2y plus 4w is equal to 2. And then the third equation is 2x plus w is equal to 3. Now, this is a system of 3 equations, right? So there's something in the calculator that we can use, and I'm going to show you what to do here. Let's go to our graphing calculator. I press math. I go over to, I'm sorry, not math, second mode. You press second, x negative 1, which is the matrix. Okay, we're going to create a matrix. You go into edit, enter on edit. You want to enter 3 by 4. And what we're doing is, what is a matrix? Matrix is not just a movie. A matrix is basically a block of information. Okay, so what we're doing is, okay, we're going to enter in just the coefficients into this matrix. And the coefficients, okay, that we're going to enter is going to look like this. So I want to enter in 4, 2, negative 5, 19, 0, 2, 4, and 2, and 2, 0, 1, and 3. You see how this is a 3 by 4 block, right? There are 3 rows and 4 columns here. So this is what I'm going to enter in. 4, 2, negative 5, 19. 4, 2, negative 5, and 19. And then I'm going to go over here. 0, 2, 4, and 2. And last thing is 2, 0, 1, 3. Okay, so once I have this information entered into the calculator, I'm going to press second mode to quit. I'm going to press second x -1 again. I'm going to go back into the matrix feature here, and I'm going to go to math. I'm going to go down to option, let me see here. I'm going to go down to option letter B, RREF, which stands for row reduced echelon form. Okay, echelon, I guess it's named after the guy who came up with this method. Okay, so we press second x -1. Under this column here, names, we're going to enter in option number 1, and then we're going to press enter. And now that is the row reduced echelon form. It's 2, 3, and -1. And it looks like I did it incorrectly then, because the answer, x will equal to 2, y is equal to 3, and w, and w is equal to -1. So where did I go wrong when I went through this? 3x minus 2 is equal to x minus w plus 1. Subtract x plus w, add 2 is equal to 3. W is equal to 3 minus 2x. That is correct. 2 minus y is equal to 2. Where did I go wrong? 2y plus 12 minus 8x is equal to 2. Subtract 12, I get 2y minus 8x is equal to -10. Plus 8x, divide by 2, -5 plus 4x. Y is equal to -5 plus 4x, so that is correct. Subtract, and I place that in here. 4x, -5 plus 4x. -5 times 3 minus 2x plus 3 is equal to 22. Distribute 2, -10 plus 8x. Distribute 5, -15 plus 10x plus 3 is equal to 22. Add 4, 8, and 10 together. I get 22x. That is correct. -10, -15 makes -25. -25 plus 3 is not 23. Is -22. Add 22 to both sides. I end up with 44. Divide both sides by 22. Of course, I end up with x is equal to 2. And since x is equal to 2, then all this stuff changes. Okay, so therefore, w, going back to this, will equal to 1, -1, and y will equal to 3, right? Since x is equal to 2, y will equal to 3. Okay, so again, I wouldn't say that this problem was challenging. It was more tedious than anything else, just because it required you to solve a system of 3 unknowns. Okay, so all right, number 42, writing in math. Explain why parallelograms are always quadrilaterals, but quadrilaterals are sometimes parallelograms, because quadrilaterals do not always have to have opposite sides parallel. Okay. Okay, so moving on. Determine whether each quadrilateral is a parallelogram. Justify your answer. This is a parallelogram. I want to give a check. Okay, that's because opposite sides are congruent. This is a parallelogram, of course, because one pair sides parallel and congruent. This is not, because none of those things are satisfied. This one is not, because we have one diagonal bisected. It needs two diagonals to be bisected. This one is, because diagonals bisect each other. And this one we don't know, because we have one pair of, we have these two sides are parallel, but we have no idea about these two. Okay? Find x and y so that the quadrilateral is a parallelogram. So opposite sides have to be congruent. So we say 2x plus 9 is equal to x plus 11. Subtract x, we get x is equal to, and subtract 9, we get x is equal to 2. And since opposite angles are congruent, we say 3y plus 19 is equal to 106. Subtract 19 from both sides, we get 3y is equal to, what is that equal to? 97? Yes, 97? No, 87, right? $87. And divide by 3, we get 29. All right. Opposite sides are congruent, so we say 4x minus 17 is equal to 2x minus 11. 2x minus 1. Subtract 2x from both sides and add 17. We get 2x is equal to 16. X divided by 2, x is equal to 8. 5y minus 13 should equal to 3y plus 5 because alternate interior angles are congruent. So 3y plus 5 is equal to 5y minus 13. We got 2y is equal to 18, divided by 2, y is equal to 9. Next, alternate interior angles are congruent, so we say y minus 8 is equal to 1/4 x, and we say that the opposite angles are congruent, so 4x minus 8 is equal to 8y minus 12. So what is this? I multiply both sides by 4. I end up with 4y minus 32 is equal to x. If I bring all the variables over to one side, I end up with 4y minus x is equal to 32. And if I do the same thing with this guy, I end up with negative 8y plus 4x is equal to 4. And if I divide both sides by 4, I end up with negative, if I divide both sides by 4, I end up with negative 2y plus x is equal to 1. This is a system of equation. If I add top and bottom equation together, I end up with 2y is equal to 33. 2y is equal to 33, or y is equal to 33 halves. Did I do that correctly? I hate second guessing myself. 4y minus 32 is equal to x. And then negative 4y, I'm sorry, 4x minus, so 8y I did make... No, I did not. Negative 8y plus 4x is equal to... I did make a mistake. So this is equal to negative 4. It's negative 4. And when I add and when I divide, this becomes negative 1. And divide, and then when I add them together, I end up with 2y is equal to 31. It still comes out to be a number that's not nice. Where did I go wrong? Y minus 8 is equal to 1/4 x. 4y 8 negative 4. 8 negative 8y plus 4x is equal to negative 4. Negative 8y plus 4x is equal to negative 4. Divide both sides by 4. Negative 2y plus x is equal to negative 1. Did I do that correctly? Y is equal to 32 over 31 over 2 then. I am not sure why this is not working out. 4y minus x. 4y minus x is equal to 32. That is correct. 4y minus 32 is equal to x. 4y minus x is equal to positive 32. So you know what? I'm just going to enter this into the calculator again. I don't know why it's not working, so I'm going to press second. X negative 1. I want to edit this. This will be a 2 by 3 matrix that I'm entering. And which equation am I entering, or how am I entering this? This will be 4, negative 1, and 32. And then negative 8, 4, and negative 4. This is what I'm entering. So 4, negative 1, 32. And then negative 8, 4, and negative 4. And I'm going to be repeating this, so I press second enter. End up with 15.5 and 30. So I didn't do anything wrong. See, I keep on second guessing myself. So y is equal to 31 over 2, which is 15.5. And what is x? X turns out to be, well, I solved it already, right? So x turns out to be 30. Okay. All right. So, all right. Find x and y so that the quadrilateral is a parallelogram. So this guy right here, and we're almost done. So 3y plus 5 is equal to 2x plus 4. And 4y minus 11 is equal to 2y plus 3. I want to solve for y here. Subtract 2y and add 11. I end up with 2y is equal to 14. Divide by 2, y is equal to 7. And since I know y is equal to 7, then I can say 2x plus 4 is equal to 26. Subtract 4 from both sides, I end up with 2x is equal to 22. Divide by 2, x is equal to 11. Opposite angles are going to be congruent, and also consecutive angles are going to be supplementary. So therefore I can say 2x plus 2y plus x plus y is equal to 180. So I can say 3x plus 3y is equal to 180. Divide both sides by 3, I end up with x plus y is equal to 60. And we can also say that 2x plus 2y is equal to 4y plus x. I'm going to bring all the variables over to one side. I end up with x minus 2y is equal to 0. So again, I end up with a system of equation. I have x plus y is equal to 60, and x minus 2y is equal to 0. If I subtract the bottom equation from the top equation there, I end up with y minus negative 2. So it's 3y is equal to 60. Y is equal to 20. And since y is equal to 20, x therefore must equal to 40. And the last problem, here we go. All right, so we know that 21, 3x plus 3y are supposed to be the same. 21 is equal to 3x plus 3y. And the other one is 2x plus 4y is equal to 6y plus 1 half x. If I bring all the variables over to one side, I end up with 3 halves x minus 2y is equal to 0. And you know what? This is what I'm going to enter into the calculator because I'm totally out of space. So this is 3, 3, and 21. 3 halves and negative 2 and 0. This is what I'm going to be entering. 3, 3, 21. 3, 3, 21, 1.5 because that's 3 halves. And what was the other number? Negative 2 and 0. Okay. So if I press second mode and I press second enter, I end up with x, 4 and 3. So I end up with x is equal to 4 and y is equal to 3. There you go.